Please ask me if you have any doubts. Okay. Now we have to declare the queue. Okay. So the this is the morning notes. So struct queue, is it visible? Is it visible to you?
Yes, sir.
Okay, so struct queue. So we have to declare the queue. Struct queue, and it has two parts. Every queue has two parts. First one is the front and second one is the rear. At the front part is used for deletion, and rear, rightmost one, is used for the insertion. So first front, and second one is the rear. But what will be the return type for front? Anyone? Return type for front pointer. Any idea? What will be the return type? Anyone? Snigdhadev, Snigdhadev, not getting any answer from Snigdhadev.
The
Shomosri,
Hello, sir.
yes, what will be the return type? Front,
Sir, I don't know.
why?
Sir, I'm not done this part.
Every queue has two parts, okay, Snigdhadev?
Okay,
So
sir.
two pointers will be there. If you are using the array implementation, then there will be two variables. Initially, you have to initialize the front and rear with -1 in case of array. In case of linked list, you have to declare the front and rear with null. Okay. Every time when you are inserting an element, that is, inserting an element means enqueuing. When you are enqueuing an element, enqueue process, when you are in enqueue process, then that is you are interested in inserting. So you have to increase the rear part by 1. Okay. In case of array, you have to increase the rear. In case of linked list implementation, just append the particular node. That is, every time you have to dynamically create a new node, that particular new node is dynamically appended at the rear part. Okay, so this is the main idea behind the insertion. In case of deletion, you have to increase the front part. Okay, so the first element that is inserted is first deleted. That's why first in first out data structure. So queue is first in first out FIFO data structure, but in case of stack, this is last element last entered element. That is only one. In case of stack, only one end is open. That's why the last entered element is popped out first. That's why last in first out, LIFO. So stack is LIFO and queue is FIFO data structure. Okay, so front, so every queue. So initially this is your front and this is your rear. Okay. When you are inserting an element, then you have to increase this rear in this position, and you have to initialize. You have to also increase the front. Okay. Next, every time you have to increase the rear when you are inserting a element. Okay. Now, if you are interested for deletion, so let the first entered element is 5, first in 5, then you increase the value of rear by 1 and you enter 10. Next, suppose the value is 15. Okay. Next, the value is 20. So which one is entered first? Which one is entered first? 5 is entered. Okay. 5 is entered. That's why you have to delete, that is DQ. Deletion, you have to delete the 5 first. That's why this is called the first in, first out. But how the deletion is happened? First, you have to increment this F by 1. Okay. Then you have to delete this particular location. Then you have to free this particular location. Okay. So this is the deletion. By advancing your front and rear, you can insert and delete the elements from the queue. So every queue has 2 pointers, front pointer and the rear pointer. Okay. Now, what will be the return type of front and rear? The front and rear both are of node type, right? Actually, both are the nodes. Suppose this is the array representation. Suppose this is the list representation. First one is your 5. We are using the SLL. Second one is the, just 1 second. Second one is the 10. So second one is the 10. Third one, this is the third one. This is your 15. And this is the last one, 20. This is the last part. That's why we made this as null. Okay. So this is your rear and 15 is connected to 20. Similarly, 10 is connected to 15 and 5 is connected to 10. So this is your front. Okay. This is the list representation of the queue, and this is the array representation of the queue. So this is your queue. Your queue has 2 parts. First part is the front part and second part is the rear part. Both are the pointers. Every front and rear pointers have 2 parts. That is the data part and the next pointer part, which points to the next node. That's why the front and rear, these 2 pointers, the return type of these 2 pointers are node type. Okay. So struct node front, and this is struct node rear. Okay. Is it clear? Not getting any response from anyone. Is it clear? Shomosri?
Yes, sir. Yes, sir.
So next you have to struct queue, and the pointer is queue. We're defining this queue pointer. Okay. Next, you have to declare the queue. You have to declare the queue. That is just creating the queue. So initially, what is the initial condition? Your front and rear, in case of array, your front and rear must be -1. Okay. The front and rear are -1 in case of array implementation. In case of linked list, the front equals to rear equals to null. Okay. This is the condition for least representation. Front and rear both are null. In case of array, front and rear are -1. So we are using the least representation. That's why let create is a function. Let create is a function that struct q, and your pointer is this. So first one is the rear and front both are null. Okay. So front is equal to null and rear is equal to null. Okay. Front and rear are null. But is it correct? Void create q. This is the create q function. Void create front is equal to null and rear is equal to null. It should be q arrow front, that is null, and this should be q arrow rear is equal to null. So this is the initialization, right? This is your initialization. Next, you have to insert. Okay. So insert function. So insert function, let the function is insert. So insert. So insert the value. So let this is the two arguments struct q, we are inserting at the q. That's why first argument is the struct q, just like struct node in case of your linked list. Struct q star q, and the value is, let the value is int n. Okay. So this n is inserted at the PR part. Okay. So what is the return type? What is the return type? Any idea? Anyone? Sneha, are you there? 9052 Sneha. Well, Uhini, 9078. Are you getting my message? Am I audible? So, Uhini, what will be the return type of your insert function? It will be struct q. Struct q, insert, that is insert the n at the q. Two arguments are there. So first, so here you have to dynamically allocate the new node. Every time you have to dynamically allocate the new node. Suppose this is the list 5, 10, 15, 20. Okay. Now suppose you have to insert 25. You have to insert 25. So what should we do? First of all, we have to create this link. So this is the first operation. Okay. So that this should be omitted, and your new node, that is 25, data part of the new node 25. So this is your rear. So this is your second operation. So this rear is cancelled out, and this is your new rear. Okay. And the third operation is the next part of the rear is made null, so that this is the last node. So there are three operations. Okay. There are three operations. So struct node, new node. Okay. Next, this new node is to be dynamically created. So first of all, we have to use the malloc function. Return type, first one is the cast type. So what is the cast type of this new node? Any idea what is the cast type? Is it struct node or is it struct queue?
Struct node.
Yes, struct node. So struct node, because your new node is of type struct node. So struct node start, and malloc, inside the malloc we have to use the size of operator and the byte size. So struct node. So the new node is, that is 25, is dynamically created. Okay. Now just insert the value. So new node at the data part, new node data. So your new node is of type struct node, and the struct node has the data part. First part is the data part. That's why new node data is equal to your n. N is inserted. Okay. Now, if this is the only one node, that is q front null, then if this is the only inserted node, then this particular 25, suppose your list is totally empty, your 25, your new node that contains the 25 is the only one node. Okay. Let this 25 is the only one node, single node. Your list is totally empty. So this is your front, at the same time this is your rear, and this should be made null, right? If your list is totally empty. Otherwise you can do this part. So if q front is null, then your new node is the only one front. So that's why we can write q front is equal to new node. Okay. Similarly, this is the only one rear. Your new node is the rear as well as front as well as rear. So q, we can write q rear. So new node. Then what should we do? Any idea? So first one, your list is totally empty. Your new node is the only one node. That's why your new node is the front, your new node is the rear. Then, any idea? What should be the next part, second part of your new node? Anyone? The second part. Getting no response after puja. Shomosri,
Yes, sir.
what should be the next action? Very simple. Tondrima, Shumon 9057.
Yes, sir.
So what should be our next action?
Sir, Q rear is equal to null.
Yes, very good. So Q rear is equal to null. So Q rear is equal to null. At the same time, Q front is equal to null. So Q front. So Q front, its next part, because your new node is the only one node. So its next part is null. Okay. At the same time, Q rear, its next part is made null. Okay. So you can write this as null. So your new node is the only one node. So this is for your list is initially empty, your new node is the only one node, 25. Otherwise, that is else there are three conditions, there are three actions. So what is the first action? What is the first action? This is the first action. That is the rear's next part is pointing to the new node. Okay. Rear's next part is pointing to the new node. So rear's next part. So we are accessing this as Q rear. Its next part is your new node, right? Okay. Then what will be the second operation? Any idea? So first operation is done. What is the second operation? Your new node now becomes the rear. Okay. So what is the appropriate line? Becomes the rear. Rear means Q arrow rear. Because we are accessing the rear as Q arrow rear. Any idea? Tondrima 9051.
Yes, sir.
Snigdhadev 9086. Your last node now becomes the rear. Your last node now becomes the rear. So Q, this is very simple. Q arrow rear is equal to new node. This is your second action. What is the third action? What is the third action? The third action is the made the next part of the rear, made the next part of the rear is equal to null. What should we write? What is the third action? Shumon?
Q rear next is equal to null.
Q rear next is equal to null. Very good. So we have to declare the third operation is our the last nodes, that is new nodes, that is the rear's next part is made null, because we are using the single linked list. We know that last node's pointer is made null. So we are accessing here the rear as q arrow rear. We are accessing the front as q arrow front. So that's why we have to write, just 1 second, q arrow rear, its next part is equal to null. Is it clear? Any confusion? Please clarify. So this is the insert. This is the total insert function. This is the total insert function in a queue. If you have any queries, please clarify. Then we have to go for the next one, that is the delete, DQ. So this is the NQ and next one is the DQ. So DQ, so first delete let delete LE. So struct Q, delete element. So delete element, let this is single argument, and struct Q star Q. Just 1 second. Here we are using the struct Q star Q. That's why we have to return every time, return Q. Just like struct in case of single linked list, circular linked list, or double linked list, struct node star, we have to return the star. Similarly, return Q. Now delete element. So delete element, how to delete the element? That is, we have to, how to delete element? We have to shift the front one. We have to delete the front one. Okay. Let this is your temporary pointer PTR. PTR is it is a pointer. That's why star PTR. But this pointer, the return type of this pointer, the return type of the front, return type of the new node, both are of struct node. So struct node PTR. Struct node PTR. Okay. Suppose that your new list is 5, 10, 15, 20, 25. Okay. So just 1 second. 5, 10, 15, 20, and next one is the 25. So this is the list from 5 to 10, from 10 to 15, 15 to 20, 20 to 25. Okay. Now, this is your front, and this is your rear. How to delete the element? How to delete an element from the queue? Any idea? Anyone? Suraj, are you there, Suraj? He's absent today. Okay, Shotish, 9036.
Yes, sir.
How to delete an element from the queue? Mind it, queue is the first in, first out. Data structure, before data structure.
Yes, sir. Yes, sir. Sir, we have to increase the front.
Yes, we have
one.
to increase the front. And then
Yes.
we have to free the first element,
Yes.
right? Very good. So first of all, we have to declare a temporary pointer PTR. Okay. Next, this PTR will store the first element, that is the front. Okay, so we have to copy the front of the queue to the PTR. So front of the queue, that is accessed by Q arrow front. So Q arrow front. Q arrow front. So Q arrow front is copied in the PTR. Okay. Now just a simple checking. If your list is totally empty, that is if Q front, totally empty means if Q front is equal to null. So Q front is equal to null. This is the initial condition. Here Q front is null. So if Q front is null, then just write printf underflow. We can't delete anything. Underflow. Okay. Otherwise, we have to store this here. We have to store this 5, that is the front, in a PTR. So this is your PTR. It has 2 parts. So this is the temporary pointer PTR. Okay, we are copying the whole node in the PTR. Okay, now this front should be changed. So this front should be now at this position. Okay, so we have to increase this front pointer. Any idea how to increase the front pointer in linked list? Any idea? Shotish, do you have any idea how to increase? In case of array, just if plus plus. But in case of linked list, any idea? Here, in case of array, we are just increasing. We are just if plus plus is enough. But here, your new Q front, that is Q front is equal to, here Q front is equal to front next. So front next means front and its next part. So its next part, that is the next part, is copied in the new front. Okay, and the deleted value, what is the deleted value? So we have to just show the deleted value. So the uh, deleted value is uh, %d. The deleted value is %d, and this will be the PTR data. Because we are interested for deletion the first element is initially copied in the PTR. Okay, first element is copied in the PTR. Here the front is copied in the PTR. This PTR is of type node because so it has two parts, data and pointer. So that particular data part is shown. The deleted value is this. Okay. Next we have to call the free function. So free PTR. So free PTR. Okay. And finally return Q. So this is the delete. This is the delete function. Any confusion? So this is the delete function and this is the insert. Now you have to display. Now you have to display the function. So there should be a display function. Display function. So inside the display function, also we take struct Q, and the return type obviously struct Q. Struct Q display. Okay. So here we use a temporary pointer for traversing. Okay. So temporary pointer for traversing, but for traversing the nodes. Okay. PTR, this temporary pointer is used for traversing the whole linked list. So its return type obviously struct node, not struct Q. Okay, because we are dealing with the nodes for PTR, your front, your new node, your rear, both all of these are of type struct node because all of these are treated as the node. Okay. But here the functions, that is insert, the display, your delete, these functions are return. This function will return the Q pointer. Its return type is struct Q. Okay. Now we have to display. That is, we have to use a loop unless and until we are at the last node. So you can use a while loop. While your PTR not is equal to rear. Okay. So while your PTR not is equal to rear, you have to traverse. Let the node is 10, 15. So this is deleted. After deletion, you have to traverse from 10 to 25. So this is your PTR. Okay. So initially this PTR is the pointing to the front one. So we have to initialize this PTR. So PTR, how to initialize this PTR with front? Any idea? Q arrow front. Okay. So this is the initialization. So this F and PTR both are initially at the same position. Okay. So PTR is equal to Q front. Okay. Now, the very basic condition that if your front is null, that is your PTR is null, your Q is totally empty. Okay. So just write this simple line. If your PTR is equal to null, if your PTR, that is your front is null, then just write down your uh, your queue is empty. Okay. Otherwise, your queue is not empty. So otherwise, what should we do? We have to increase. So while what is the condition for reaching the last node? What is the condition? If your PTR not is equal to rear, that is we are accessing the rear as Q arrow rear, while your PTR not is equal to rear. Okay. So this is the condition for you are not at the last node. Who will Shomolina 9081? Are you there? Shomolina left the meeting after the call. She left the meeting. (9081) Shomolina.
Yes, sir.
So what will be the next line? Line number 58 and 59. You are at the initially you are at the front one. Okay.
No,
So we are using the temporary pointer PTR. Actually, this is the node structure. So struct node PTR. So we initialize this PTR with the front. We are accessing the front as Q arrow front. Okay. So initially your PTR front are same. And this is just a simple checking. Your front is not null. That is, if it is null, then Q is empty. Otherwise we have to traverse. Okay. So we have to traverse up to the last node. What is the last node? Your last node is the rear, right? Your
Yes.
last node is the rear, and the rear's condition is rear's next part is null. So we here the rear's next part is made null. Okay. So while PTR not equal to Q rear. So this is the condition.
Yes.
Then line number 58 and 59. What will be the line number 58 and 59?
Print %d PTR arrow data, and
Okay.
then PTR equals to PTR arrow next.
PTR arrow next. Okay. Very good. So first one we have to printf. So the data part is %d. Okay, %d, and let this is tab. Okay, and this will be PTR arrow, the data part. And we have to advance the pointer. So PTR is equal to PTR arrow next. Right? And for last nodes printing, we have to write the %d PTR data. Okay. And this is the else part complete, and return. So this is the display function. So this is the display function. Okay. This is the delete function, DQ, and this is the NQ, insert function. Okay. This is the create list, and this is the queue. Queue has two parts, front and rear, and this is the just like object creation, pointer queue, and this is the node structure, data part, and next part. Is it clear? The main is not complete yet. We have to complete the main now. So first part, in the main, do, we are using the do while loop. Let do while our something. So do something. So do something. First write down. Write down printf let first one is the insert. Okay. First one is the insert. Second one is the delete. Delete and third one let is the display. Display. Okay. So just enter your option. Enter your option. Enter your option. So scanf, we have to insert the option. So option is, let the option is this is %d. So option, we have to declare this option. So this will be of type. Its return type is int op. Okay, int op. And now we have to use switch case. Okay, so switch is passed by op. So first one, case one. Let case one. Case one. Case one. First, let this is the enqueue. Printf enter the number. Enter the number for insertion. Enter the number for insertion. Okay. So enter the number for insertion. So this should be, there should be another variable. That's why we have to use the %d. Let this is in. So we have to declare this op and in. Next one is the q. Q is equal to insert. So insert your function name insert. So insert q and n. Insert q and n, and then break case 2. That is delete. So delete means just q is equal to delete le. Delete le. So delete le. Where is delete le? Delete le is, that is q. So q. So delete le is just single argument, and break. Case 3. Case 3. So case 3 is your display. Display. So display function. So display function, inside the display function, we are using just one argument q and break. Break. Okay. So here, what will be the condition? Any idea? Line number 89. So there are three cases. Any idea? Snigdhadev? Shomojit?
Sir,
90. Yes.
sir,
Yes, sir.
Shomosri,
yes, sir.
you are asking something?
Sir, while এর ওখানে option not equal to 4 হবে।
OP not is equal to 4. Yes, OP not is equal to 4. OP not is equal to 4 and OP not is equal to 4 and finally return 0. So this is our uh, full program. Now let build and run. So enter your option. Let 1. Enter the value. Enter the, is it visible?
Yes, sir.
Enter the value. So enter the value 5, 10, 15, 20. So 5, 10, 15, 20, 5. Five. What is the problem? Insert function. Stuck in these intermediate steps. So this is the insert. Can you find out the errors? N, your N is inserted. Your N is inserted, but delete. Let display. Options are not running. Why? Oh, struct queue. So before this, we have to create the one. Create queue. Create the queue. Jhumadi, Jumadi, are you there?
বলুন বলুন
Can you find
আমি
out the
জুমা
error?
বলছি। হ্যাঁ দেখলাম এরর এসছে প্লিজ প্রসেস টার্মিনেটেড উইথ স্ট্যাটাস এটা
Yes.
টার্মিনেশন এরর লাইন নাম্বার নেই আমি দেখছি কি
This is the insert function. Jumati, is it visible to you?
হ্যাঁ ভিজিবল ভিজিবল
Node is declared. First node is declared. The next the queue is declared. Okay.
হ্যাঁ
Next queue star is declared, and this is our create function, create queue function. Okay. Its rear part is made null and front part is made null. Next, this is the insert function. Inside the insert function, the new node is there. It is dynamically created, and the value is inserted at the data part of the new node. And if it is the only single node, then its front part is, if the front part is made null, then this is the only one node. That's why q arrow front is equal to new node and q arrow rear is equal to new node, and q arrow front next is equal to q arrow rear next is equal to null. Otherwise your rear next is the new node, and new node becomes rear, and rear's new node rear's next is made null, and we have to return the queue. Okay. Next, delete. Delete means we have to delete the first one. So ptr is declared first, then ptr is, the front part is copied in the ptr, and if the front part is null, underflow, otherwise front, that is next part of front is now becomes the new front, and the deleted value is data ptr, and this is the display function. For displaying, the ptr is the temporary pointer, and initially q front is ptr. If ptr is null, empty, and while your ptr not is equal to rear, so we have to first display the data and advance, and this is for last line, and return q. Now this is the main function. Inside the main function, first of all we have to call the create. Call the create function, but create queue. Delete. So this is the option and option switch case. Sorry. Jhumadi, can you find out errors?
No, so far I did not see.
Delete element.
রিটার্ন 0 এই তো সবই ঠিক আছে, এভরিথিং ইজ ওকে। রিটার্ন 0 বলে কেন প্রবলেম?
Devashish Da?
আচ্ছা, অপশন 4 বা ডিফল্ট অপশনটা দিয়ে দিন।
Default, okay.
ডিফল্টটা দিয়ে দেখেন যদি সো ফার আই ডিড নট নো সি এনি এরর। আর এখানে ডিফল্টটা দিয়ে দিন কি ডিফল্ট ব্রেক বা কিছু, এই যে অপশন 4 এর জন্য।
Exit, for exit.
হ্যাঁ, এক্সিট 0 বা এই যে অপশন 4 বা ডিফল্টের একটা কিছু রাখেন, ডিফল্ট ব্রেক বা অপশন 4
Is it required? I'm just sending this particular code. 1 second.